Welcome to the another session of belt drives. In this lecture, we will see about the geometrical relationships in between the small pulley and bigger pulley and the length of the belt drives. Basically, the belt drives has two types of construction, open belt and cross belt drive. Here are the two images which shows the open belt drive system as well as the cross belt drive system. Okay. First, we will see the open belt drive system, then we will move towards the cross belt drive. The open belt drive is a belt drive in which the belt proceeds from the top of the one pulley to the top of the another pulley without crossing. While in crossed system, the belt is crossed from one pulley to the another pulley. It has advantages as well as disadvantages. In both the cases, driving and the driven shafts are parallel with each other. In open belt drives, both the driving and driven pulleys rotates in the same direction, while in cross pulleys, the direction is opposite with each other. In cross belt drives, angle of rope is more than 180 degree, while that of the open belt drive is less than 180 degree. As the angle of rev increases, the slippage problem reduces. In cross belt drive, the belt rubs against itself while crossing. Also, belt has to bend in the two different planes. Okay, these two factors increase the wear and reduce the life of the belt. In open belt drives, when the center distance is more, the belt whips, that is, vibrates in a direction perpendicular to the direction of the motion. So it will vibrate in this direction. Both these factors limits the use of non-open belt drive. Cross belt drive has no such limitation. Open belt drives are more popular than the cross belt drives. First, we will see the open belt drive system in which there are two pulleys used. One is the smaller pulley and another is the bigger pulley. Let's see the open belt drive system. Here is the smaller pulley and here is the bigger pulley. The smaller pulley has an angle of wrap as alpha x, while the bigger pulley has angle of wrap as alpha d. D is the diameter of big pulley and small d is the diameter of smaller pulley. P is the center distance which will be between 0 to 1 or O to 1, and beta is the angle with the vertical axis of that of the end of the pulley. Then we will draw one line from O to G which is perpendicular to O1C, which makes the rectangle OBCG, as well as we have got one right angle triangle as O1G. We are going to use trigonometric relations to find out the length of the pulley. Basically, the length of the pulley is calculated as the arc AFAB plus this is called BC plus arc CD and the chord EF. If we are going to sum up these lengths, then we will get the overall length which is required for the build on the pulleys. Okay, then we will use some trigonometric relations. First, we will focus on triangle OGO1, in which sine alpha is the opposite to the hypotenuse. Here, hypotenuse is O to O1 and opposite side is O1 to G. So, sine beta is equals to O1G by O1, which equals to O1C minus GC upon O2 O1. Okay, O1C minus GC is equals to the OB. So, O1C is the diameter or radius of this bigger pulley, while O2B is the radius of smaller pulley. So, we can write here sin beta is equals to d by d minus small d by 2 divided by where C is the center distance. We are getting one relationship as D minus D by 2C. So, that equals to D minus D by 2C. Also, alpha S. Here, this angle is 180 minus beta minus beta. That is 180 minus 2 beta. As alpha B is equals to 180 plus beta. That is 180 plus 2 beta. Here we are going to include the values of beta. Therefore, alpha S will be equal to 180 minus 2 sine inverse of D minus D by 2C. Also, the alpha beta will be equals to 180 plus 2 sine inverse of D minus D by 2C. Referring to the figure again, we will calculate the length of the belt as length is equal to arc FAB plus chord BC plus arc CDE plus EF. We are knowing that the arc subtended by the circle creates an angle of alpha S with the outer edges of B and F. So as per the mathematics or as per the geometry, we are knowing that the arc length FAB can be calculated as radius d by 2 into the anga substituted as alpha S. So d by 2 into alpha S. Similarly, for alpha B, our distance CDE, which is subtended by an angle alpha B, is given by alpha B into d by 2, small capital D by 2. So, also we can write alpha is equal to pi minus 2 beta and alpha b is equal to pi plus 2 beta. And this OG and OC. OG, O to G, is the cos beta relation. Cos beta is equal to O1G divided by O1. So we are writing here C into cos beta. So we'll get L is equal to pi into D plus D by 2 plus beta, D minus D plus 2C plus all beta. We are considering for the small values of beta as this the angle beta is more smaller than alpha B and alpha S. So we can neglect the sign beta. We will get beta is equal to D minus D by 2C. Therefore, cos beta is equal to 1 minus 2 sin square beta by 2 is equal to 1 minus beta square by 2 equal to 1 minus D square by h square. Substituting these values of beta and cos beta, equation A, we can get by solving this relation length which is required for the open belt drive system in the terms of center distance and diameter of the pulleys. We can get this relation as L is equal to 2C plus pi into D plus D by 2 plus D minus D bracket square by 4C. As we are knowing the cross belt, there is one change is that angle beta is greater than that of 180 plus. So here, similar construction can be done. O to G, which is perpendicular to the line O1C, the extended portion, we can solve this equation and then we can get that length L for the cross belt drives is given by L is equal to 2 please plus pi D plus D by 2 plus D plus D square by 4C, which should be noted that in above expression, D and D are pitch length of the pulleys, while L is the pitch length of the belt. So these relations will give the length of the pulley. Another parameter is the width. By knowing these two parameters, we can select the belts. Okay. Then we will move towards the belt selection. Let's see the selection of belts from the manufacturer's catalog. In our practice, designer has to select the belt from the manufacturer's catalog. For this selection of a proper belt for the given application, we should know the following requirements. Power to be transmitted. How much power is going to be transmitted from one location to another, which matters while selecting a belt. If we are going to select the belt which is having a less power capacity, carrying capacity, which affects its selection as well as its service life. The input and the output speeds. Okay. Input and output speed means the smaller pulley and bigger pulley speed can be measured with the help of tachometer. Then center distance between the, depending upon the availability of the space. In which location we are going to build that belt drives, its distance or space is calculation is required while selecting the belt. If you are having a compact system, then we can go for the way belt rise. For a flat belt, exact calculation of the center distance is required. Basic procedure followed in these steps which we are going to learn. These are the for the Dunlop Rubber Corporation Limited, India Limited is discussed in this select total sections. This same procedures can be followed for the other manufacturers. Only the difference is power rating. It's a variety of the belt offered. We can select that one with the help of this. The basic procedure for the belt selection is we have to first find out the maximum power capacity which can be used for the design purpose. So here represent kilowatt max is nothing but the power transmitted by the belt for the design purpose. kW is the actual power transmitted by the belt in the given application. This will be decided by the prime movers or engine or any other uh, element which gives power to the driving pulley. Then FA is the load correction factor. The values of load correction factor are calculated from this table known as load correction factor table. If your node is a normal load, which means that you are going to use your belt in normal applications, like you are going to connect one shaft with another shaft, having a conveyor system with low load that comes under the normal load, for which the design load can be taken as the design power is can be taken as the actual power. Next category is the steady load. Examples which are centrifugal pumps. If you are going to operate a centrifugal pump with the help of belts, then you can use 1.2 as a power correction factor. Fans that are nothing but the small exhaust fans, etc., radiator fan, etc. Light machine tools like a lathe machine, drilling machine, or a grinding machine for the tool shaping and conveyors, which comes under the steady load category. You can use 1.2 as a value. Then intermediate loads considered as heavy duty fans, which are required in compressors, boilers, as a draft fans or draught fans, can be categorized into the intermediate load. Also, blowers, compressors, reciprocating pumps, line shafts, heavy duty machines, which are operated with the help of flat belt drives, comes under the intermediate load. We can take value as a 1.3. For the shock load category, vacuum pumps, rolling mills, hammers, grinders are considered, which for these types of loads, we can take 1.5 as a correction factor. After finding the power transmitting capacities, the arc of contact should be 180 degree. The minimum value for the arc of contact is 150 degree. If the arc of contact is decreases, then similarly power transmitting capacity will be lowered. So we are going to utilize one factor called as arc of contact factor FD, which will compensate this effect of arc of contact. The values are angle varies from 120 to 200 degree. Then accordingly, FD will range from 1.32 to 0.94. For Dunlop configuration, we are having two types of belt systems, high belt, duck belting, and four duck belting. For these two types of varieties, here we have mentioned the power rating capacity or power transmitting capacity. For any manufacturer, these are the varieties of the belts. So you can have the 7 to 8 categories for the particular manufacturer. You have to look into the catalog and find out the transmitting capacity of the particular type of belt. According to that one, we are going to select the belts. Next, after knowing these tables, we will move towards the actual selection procedure. Here, this is the table which represents the standard weights for the ply system. If three ply system is there, then accordingly you can use 40, 25 mm, 40 mm, 50 mm, 63 and 76 mm belt. For 4 ply, 40, 44, 50, 63, 76, 90, 100, 112, 125, 152 mm width belts can be utilized. For 5 ply system, 76, 100, 112, 125, 152 mm which belts are available. For 6 plies, 112, 125, 152, 180, 200 mm width belts are used. Preferred pulley diameters are 100 to 1000 mm. From these categories, we are going to select the diameters of pulleys for smaller as well as the bigger pulley. There are total 8 steps through which we can calculate or we can select the proper belt for our application. We should know power transmitting capacity, center distance required in order to have this selection procedure knowledge. First step is the optimal belt velocity of the bundle of belts is should be taken as 17.8 to 22.9 meter per second. Assuming the 18 meter per second as the standard size, you can have the relationship to find out the smaller pulley diameter as D is equal to 16 to 10 raised to 3 into V upon pi into N, where V is the belt velocity. We are going to take in the range of 17.8 to 22.9 meter per second, and N is the input speed of or RPM of the smaller pulley. The diameter of bigger pulley can be calculated with the help of this relation D is equal to D into input speed upon output speed. After this calculation, we have to modify the values of D, that is diameter, in range of this particular range. Select this standard size of pulleys, then accordingly modify the belt velocity. After modifying the diameters and the belt velocity, we can move further process. Then we have to determine the load correction factor from the table given above, which depends upon the type of load. Find out the maximum power for the purpose of belt selection by following relation, that is Kw max is equal to Fa into Kw. By calculating maximum power to be transmitted, you can go for further process, that is calculating the angle of wrap for the smaller pulley. By the relation, alpha is equal to 180 minus 2 sin inverse of D plus D by 2. Find the arc of contact factor HD from the table. Then we are going to correct the power by the formula as Kw corrected is equal to Kw max into Ft. Then calculate the corrected power rating for the belt by following relationship. For high-speed belt, corrected power rating will be 0.0118 V into 5.08. For the full take-up systems, that is rating is given by 0.0147 V upon 5.08. There is the correct belt velocity. We are going to calculate it in step 1. Then we are going to calculate the product of width into the number of plies is equals to the corrected power upon corrected belt rating. That is Kw corrected upon corrected Kw rating of the belt. Here we are going to use in this step the alternative solution methods. You can assume the number of plies or you are directly given the number of plies required for the particular application. Accordingly, you can calculate the widths which are based on this table. Combine your values with all in the standard format. So it will give us the relationship. Okay. This procedure is followed, and then finally we are going to calculate the belt length by using the relationship as L is equal to 2C plus pi into D plus D by 2 plus D minus D bracket square by 4C. This above procedure is explained in further examples here. Okay. This one is the numerical where it is required to select a belt drive for a compressor running at 720 RPM, which is driven by 25 kilowatt 1440 RPM motor. Space is available for center distance of 3 meters. The belt is open type. Here we are given the data as open type system is used, having center distance is 3 meters. Then speed of the pulley is N is equal to 1440 RPM. Maximum power transmitting capacity is kilowatt 25 and speed is 720 RPM. Okay, N1 is 1440 and N2 is the 720. Then we are going to draw a sketch. This represents the D1 as a smaller pulley diameter, capital D as a bigger pulley diameter, RPM of both the pulleys and center distance. Here we are going to calculate the belt velocity V. Using belt velocity V as a 18 meter per second, smaller diameter can be calculated as to 38.73 mm. By selecting the preferred pulley diameter, that is comes to 250, as this value is 238, which is comes nearer to the 250. So we are rounding it up to the 250. So bigger diameter will be 2 into 250. Okay, where 2 is uh, ratio of these two. 1440 upon 720, which gives value of 2. Or uh, the speed of the smaller pulley is 2 times that of the bigger pulley. D is equal to 2 into 50, which gives us value as 500 mm. So we are using 250 mm smaller pulley and for 500 mm bigger pulley. Then we are going to calculate the belt value as belt velocity is equals to 18.85 meter per second. The maximum power for the selection is given by as the load correction factor for the compressor, as this belt is used for driving the compressor, which comes under the this compressor comes under the intermediate load. The value will be 1.3 and 1.3 into 25, which gives maximum power is equal to 32.5 kilowatt. Then we will calculate the arc of contact factor by alpha S. Alpha S can be calculated by this formula, which comes nearer to 175.23. Assuming linear interpolation, the arc of contact factor can be calculated as FD is equal to 1.0118, as this angle is between these two values. So we are going to use interpolation method. Okay, then we will have a corrected power calculation 1.019 into 32.5, which equals to 33.12 kilowatt. Then corrected power rating of the belt, selecting a high-speed belt, we will have the corrected belt rating as 0.0438 kilowatt. Then for the selection of belt, we will find out the product of width into number of plies, which comes nearer to 756.17. We will choose 4 plies, 5 plies and 6 plies blade, and we will calculate the widths. For the, we shall select high speed belt of 152 mm, preferred width of 5 plies by this relation. Okay, this is 152 is the maximum. This is 126 and 189. So this is nearer value. Should we will go for 152 mm ply width and 5 plies. The belt length can be calculated by this formula. L is equal to 2c plus pi into d plus d by 2 plus d minus d bracket square by 4c, which comes nearer to the 7183.31 mm. So the solution for this will be a high-speed belt of 152 mm with 5 plies and the length of 7,100 meter mm length. So in this lesson, we will learn the selection of the belts on the manufacturer's catalogue. Hope you understand.